Okay, so these look really complicated. However, they're not as complicated as they look. So if you notice, I have a sine squared, I have a sine, and a no sine. So if I take x to be equal to sine of theta, I can now rewrite this equation so that 2x squared minus 3x plus 1 equals 0. And now that equation looks a lot easier for me to solve. So I have a quadratic equation, I have options. I could complete the square, I could use the quadratic formula, or I could factor. And what jumps out to me here is factoring. So if I factor it, I get 2x minus 1 and x minus 1 equals 0. So if I double check, I get 2x squared minus 2x minus another x, that gives me minus 3x, and then negative 1 times negative 1 is positive 1. So when I go to solve these, I get that x is equal to positive 1/2 and x is equal to positive 1. And so what I can do now is, using the fact that x is equal to sine of theta, is replace x with sine of theta. So what I'm looking at now is the sine of theta equaling 1/2 and the sine of theta equaling 1. So again, using our unit circle, we want to figure out where do these things happen, and we're not restricting our quadrants or anything. We're just looking in general in the entire unit circle. And we're looking between 0 and 2 pi. Things would change perhaps if we're looking just between 0 and 2 pi, or 0 and pi, or pi and 2 pi. Things might change, but we're doing a full revolution. So sine is equal to 1/2. I know that it's equal to, over here in this quadrant and in this quadrant, so this one's at pi over 6, this one's at 5 pi over 6. So in this case, theta is going to equal pi over 6 and 5 pi over 6. So I already have 2 just for this one part. But now I need to think about where sine is equal to 1. And so when I look at my unit circle, I see that that does in fact happen right here at pi over 2. So in this case, theta is going to equal pi over 2. So that's it. Those are my 3 answers. There's no other place between 0 and 2 pi that sine is equal to either 1/2 or positive 1. So my answers for theta are pi over 6, pi over 2, and 5 pi over 6. And it doesn't matter the order that you write them, it just matters that they're all 3 there. Okay, so this next one is looking at a cosine of theta plus 3 equals 2 sine squared. Now, the important thing to keep in mind is Pythagorean theorem, right? We can do x squared plus y squared equals 1. So if I think about it in a triangle, I also have my leg squared plus leg squared equals hypotenuse squared. We also have a trig identity, that's sine squared of theta plus cosine squared of theta equals 1. And this is probably one of the most important trig identities that you'll ever see, and really the only one we're going to use this year. So you definitely want to have this one memorized. So here I see that I have a cosine and I have a sine squared, and that's really inconvenient because I want them to be the same, either both be cosine or both be sine. And so I know one is probably going to be squared, and so I need to think about how, using this identity is going to be really helpful because I can easily isolate it for sine squared. However, for cosine, just by itself, it's going to be really tricky to write in terms of sine. I'd have to have a square root, I'd have to have some really ugly things that really don't sound beneficial. So what I'm going to do is substitute whatever I can get for sine squared. So I'm going to isolate sine squared. So I'm going to subtract cosine squared from both sides. And so what I see is sine squared is equal to 1 minus cosine squared. So we're going to take this right here, 1 minus cosine squared, and put that in just for sine squared because they are equivalent. So I get 3 cosine of theta plus 3 equals 2, in parentheses, 1 minus cosine squared theta. So what I want to do is get everything on one side to kind of look how this one did, distribute, combine like terms, etc. So this 2 is going to go to both things. So again, 3 cosine of theta plus 3 equals 2 minus 2 cosine of theta. I'm now going to move both of these things to the other side, so I'm adding 2 cosine theta to both sides, 2 cosine squared theta, and then subtracting 2. And so this side will become 0, and I'll have 2 cosine squared theta plus 3 cosine of theta plus 1 equals 0. And so again, I have something very similar to what I saw before. Actually, it's the same numbers, except I have a positive 3x instead of a negative. And so this time, instead of using sine, right, for x, we're going to say x is equal to cosine of theta. So when I do that, I get 2x squared plus 3x plus 1 equals 0. You could factor, you could complete the square, you could use the quadratic formula. So I get 2x plus 1 and x plus 1, because I just have a positive here. That's all that changed from above. So x is now negative 1/2 or negative 1. So what we're looking at now is when the cosine of theta is equal to negative 1/2 and when cosine of theta is equal to negative 1. So cosine is negative in quadrants 2 and 3. And so I know that that's going to be happening at 2 pi over 3 and 4 pi over 3. And those are the only places where cosine is negative, between 0 and 2 pi. Then cosine is negative 1. I know that only happens at one place, and that's here at pi. So my answers would be 2 pi over 3, pi, and 4 pi over 3. And so those are the 3 places on our unit circle that would fit and work into this equation. So if you were to substitute in theta right here for sine, if you squared that value, multiplied it by 2, and then set that equal to 3 times the cosine of that value plus 3, you would get the same thing on both sides. I actually find these types of equations to be much easier than the ones that we did last time. Okay, so what I want you to do is to try to solve this one on your own. I would highly encourage you to use this identity I highlighted in blue, that's sine squared plus cosine squared equals 1, and manipulate it so that you can get the same thing, so that you don't have a cosine squared and a sine. And then see how far you can get, at least being able to substitute in and getting x equals something, what is your equation, and kind of going from there. Okay, so let's go through this. So I know that this is really not what we need, because we have something like cosine squared plus sine minus 2 equals 0. And so I'm going to use the fact that I know that sine squared plus cosine squared equals 1, and I'm going to isolate cosine squared this time. So cosine squared of theta would equal 1 minus sine squared theta. So cosine squared, so I'm going to replace this 1 minus sine squared theta plus sine of theta minus 2 equals 0. So I really just have 1 minus sine squared theta plus sine theta minus 2 equals 0. Let's combine like terms. Negative sine squared theta plus sine theta. 1 minus 2 is negative 1 equals 0. And then this is really not fun for this to be negative, so let's just divide everything by negative 1. So I get sine of theta minus sine squared theta minus sine theta minus 1 equals 0. And at this point we should think, what should I substitute in for sine? Well, let's use x. So x is going to be equal to sine of theta. So what we have, I'll write it over here, is x squared minus x minus 1 equals 0. And I don't know a way that I can factor this, because if I factor it with x minus 1, x plus 1, I don't have a middle term. And so I know that I can't factor it, and so because of that, we're actually going to have to use the quadratic formula. Now you could complete the square if you wanted to, but I think I'm going to use quadratic formula. So doesn't factor, use the quadratic formula. Okay, so when I do that, x is equal to negative b, so that would be negative negative 1 plus or minus the square root of b squared minus 4ac. Is he negative 1? Oh, I didn't change it. It should be positive 1. That should be just positive 1. All over 2 times 1. So I had to go back. I forgot to divide this by negative 1 to make this positive. So just make sure that you've changed those signs as you go. So I get x to be 1 plus or minus 1 minus 4 in the square root all over 2. So I get x 1 plus or minus square root of negative 3 over 2. Uh-oh, this is a problem. This is an imaginary number. And so since I can't get a real solution from this, because I get an imaginary solution, then our answer is no real solution. And that's it. We can't solve and get x to be something that's real. So because of that, I can't put a non-real number here and say what is the sign of it, because we can only take the sign of positive values and get a positive value. And so that's it about trig equation.